Okay. Good evening, everyone. And yeah, once again, for those who are joining us, we are grateful for setting aside time and being part of us this evening. So we were supposed to start a little bit earlier, but for some reason, we pushed this event later on due to public demand so that most of the people who are also interested in the session could get time and join. So before we dive deep into the session, I'll first introduce our guest. Then we get at least to understand more about what we are doing. But for those who are joining us for the first time, this is the Expert Bytes community. We are a volunteer-driven technology platform, and we also share knowledge. We are focused on practical conversations around modern software engineering, innovation, digital transformation, and emerging technologies. Our sessions bring together developers, engineers, students, startup founders, and anyone interested in tech to learn from industry experts like the one we are having here today. We learn that through practical and insightful discussions. As we are in the modern world, most of us have interacted with what are known as APIs, especially if you are from a tech background as a software developer. And fintech platforms, AI systems, healthcare applications, USSD services, and the mobile ecosystems. All these platforms run on APIs, and they've become the backbone of digital communication and integration. So our session today is about building modern APIs, and we are seeking to explore what it truly means to build a modern API in a fast-changing technology landscape. We will be focusing on scalability, things to do with security, performance, integrations, the architecture, and generally the developer experience itself. And if you are new here, we are live on YouTube. And if you're not a member on our YouTube platform, this is a chance to be part of it by subscribing. It's free of charge to subscribe, and also share this content with your friends and anyone who is interested in tech to help us grow our learning community. So that said, if you have any questions, we have a live chat box just in the comment section. Drop any question that you have, any clarification, any suggestion. We would be glad to hear from you. So I'd love to introduce our speaker, who is Vincent. Vincent is a tech guru, but he let us know much more about himself that we don't know about him. So Vincent, kindly, if you can just, let the audience know much about you and what you'd love us to know with regard to our session today before we kick in. Over to you, Vincent.
Okay. Thank you, Douglas. So I think for myself is so I'm Vincent Omondi. So first of all, I call myself two things. So there are two things that I love doing that I call myself with. First of all, I'm a dad. I'm a stay-at-home dad. So I spend most of my time kind of like raising our kids. Then I'm also a plumber. So professionally, I'm a plumber. So either across data or just across just systems. So I basically kind of like any kind of like system problem that any person may have. So I am sort of your guy. So I've also had an experience working across government, working across startup landscape, as well as kind of like multinational companies, both in across Kenya, Africa, and United States. So for a few, I've pretty much worked. If you are Kenyan and you ever used the passport portal, so sort of like part of the team that created that first version of that system. I've also worked as an engineering team lead at AutoCheck Africa, especially focusing on data systems. Worked at Omdena as a lead MLOps engineer across LATAM and US. Then of late, of course, I've been getting myself kind of like tipping my feet mostly within the entrepreneurial space. So I'm the co-founder and CTO stroke CEO at PayHero Kenya stroke PayHero Africa, as well as also the co-founder and CTO at Paid HQ. Yes. So yeah, glad to be here and looking forward for a fruitful conversation. Thank you.
Okay. Thank you, Mr. Vincent. That's quite wonderful introduction in terms of your tech background. I'm sure you tend to love the industry so much, just as you love your kids. So possibly you have two kids. That is in terms of the industry and also now what you do in tech. But before we go into the session, Vincent, maybe for those who are joining us for the first time in our session, how has it been for you, especially with your background? How has it been transiting from what you've been doing and now getting into tech? Just briefly.
Yeah. So I think probably is if in case you're a mathematician or if you're a statistician, then tech is a very, very good field to transition into. It's I think it's one of the few fields which meritocracy kind of like goes above anything else. Probably for context is that most people probably don't know that I'm not really a computer science graduate myself. So in school I studied financial economics, so which is more of an art and statistics than it is kind of like I believe logic and systems as you'll consider probably engineering. So for myself, I'm mostly a self-taught person, even though guided. But the key thing that I've noticed, despite kind of having a lot of problems, because I do understand kind of like getting that first trying to understand the very first if statement, how it works, it's really, really difficult. But what I do think is that within tech is if you kind of like have that consistency and repeat something over and over and over and over, you probably is going to make it. For example, because I think over time, if you understand some basic logic or how logic generally form, then of course you're sort of going to make it. So I think for me, tech is the key thing that I love about it because like the path to being kind of like a technical person is very, very clear. There's one way to interview. You just have to be good at lead code. Nobody's ever. I've worked pretty much across the globe. I've worked for a company in Luxembourg. I've worked for companies in US, Nigeria, South Africa, and Kenya. And I've never been asked even for my certificate. I don't even remember if I ever picked my certificate from even my sort of like my high school certificate. I've never picked those certificates. So that kind of like shows, for example, from a technical perspective, in case you want to get into a technology field, nothing's going to change about that thing. Is that the line for computers is very, very clear. And if you just strive to improve yourself and so like become one of the best people in any field that you work on, then yeah, you are pretty much going to make it. And it's a very, very enjoyable and rewarding field, especially when you get to kind of like people actually use your product, get feedback on those particular things, and see how actually the impact that you're having on people's lives actually make with the actual product that you're creating. So from a personal perspective, it's something that I think is the road to it is very clear. And also, as you work on things, it's a very, very rewarding field in that you actually have the feeling that you are having impact on the solution that you are creating. Yes.
I really love your journey, Mr. Vincent. And I know for anyone who is listening, they are possibly encouraged. It's not such an uphill task to switch from any background into tech, especially if you are determined. So Mr. Vincent is going to take us through APIs, building modern APIs. And I know he's very ready to let us know what APIs are and what do they do. So over to you, Mr. Vincent.
Yeah. So yeah, thanks, Douglas. So I think we are going to follow this thing pretty much into so like in we are going to have kind of like a presentational side of things, and we're also going to have kind of like a demo side of things. And let me see where I can share from. Yeah, I think I can share from there. Allow me share my screen. Okay.
Yeah, sure. It's very ready for you to share. I'll let you know once it's up. So as
I may
Vincent is
exit and enter because I think I've never shared on this. So my Mac is asking for permission. So I think I may just exit a second before I come back.
okay, sure. No worry. All right. So as Vincent is preparing his slides, once again, welcome to our show today. You can utilize the chat box or the live chat comment section. For those who had dropped their questions earlier on, we've captured them and we'll be sharing them in the session as Vincent presents. So any question you have, any clarification, any kind of comment you have, please let us know. And also in the chat box, you can type in terms of the kind of specific things you have on APIs and you'd want them clarified in this session. This is the time now. I can see Vincent is now ready. So okay. Cool. So over to you, Vincent.
Okay, sure. Thank you. So I think, like I was mentioning, we are going to follow this thing in two ways. I think, Douglas, you can sort of like nudge me so that, again, I don't take much of a time, so that we just stay within the bounds of the time. So
Okay.
we'll follow this in two sessions. We'll have the presentation side of things, and then we'll also have kind of like the demo side of things. So I'll try kind of like divide it probably half by half, yeah, as much as possible. So yeah, so building APIs that scale. So I'll probably talk about this thing. If you can build a API that scale, please build a API that scale. Yeah, I think because writing systems is always something that's very, very difficult. I've seen this thing over and over and over, and always the mantra always is that there is either two worlds for people, which is either you build your APIs, for example, that follows a monolithic approach, or you build your APIs that follows a microservices approach. There's always kind of like there's no kind of like a middle ground, especially if you're within the tech space. So either you are a microservice, or you are, or the people say you are a monolith, or you are doing microservices wrong, for example. So I think that's probably the key thing that we want to nudge today and find a way, for example, if we can build something that suits your context, for example. So who's me? I think you've pretty much heard who's me. So of course, we're going to start with part A, which is API integrations. So again, if you're building any sort of like whatever the place that you are on, if you're building any system, API integration is a very, very core center of anything that you're going to do. So if you let's say, for example, you are a fintech and you love to integrate banks, you love to integrate MNOs, mobile money providers, you love to integrate kind of like a KYC provider, like APIs is the thing that actually brings the system together, for example. Yes. And the key part that most people actually forget about APIs is that APIs are distributed by nature, because you're not going to get a service from one provider that gives you everything. For example, you are going to find a way which, for example, there is KYC, there is payments, whatever the case that generally is happening across the system, for example. So even from that particular design model, that APIs are distributed by nature, not really to the core how distributed systems work, but by the fact that you'll always find that you'll be dealing with multiple parties that have multiple problems, or kind of like multiple features within one single kind of like you as a business. So yes. So again, so what's an API goal for a business? I think Douglas has mentioned what API is. Again, API is just, it's a mode which applications are able to communicate with each other or change information. So you always realize is that if you're a business, you are relying on other APIs, for example. So the moment you're relying on other APIs, then it means that the value that you're providing is above that particular API. So for example, the use case, for example, let's say you're in Kenya and you use M-PESA, and let's say you build your fintech around M-PESA, or let's say not even M-PESA, let's say Smile ID, for example, in Kenya, or not even Smile ID, we call it, there's a way we call Smile ID integration. You provide value above that particular Smile ID. So the Smile ID is the API which can like accept some data and sort of like gives you some particular response. So either there are two things that you are doing. So you are sort of like having, either you are making it easy. So you're making it, generally, most of the cases, you're making something accessible. So think of like the Vercel and the AWS. Vercel is just, using AWS console is a very, very difficult thing to kind of like get yourself into. So what probably Vercel provides is a very accessible layer of how to use AWS. So that is mostly what an API layer mostly is for business, is that you're taking one particular API and you're sort of like having an accessibility layer around it and just providing the right abstractions that give most value to users who are not, don't want to worry about the underlying infrastructure, for example. So if let's say I'm saving and I'm using your application to save, I should not generally worry about let's say the M-PESA or the Airtel things, the nitty-gritties that lies, let's say, between Airtel and let's say wherever, any provider that you use for that particular case. So the main goal is that if you create a very good API product, they should not change how the users interact with a particular domain. So let's say in this use case, for example, for a fintech. So the way they interact, you build abstraction around that thing so that now it feels much more natural to them. You don't say, here we do it X, Y, and Z, for example. So rather give them the modes of their current interaction. So if you come and you realize that, for example, I'll give, for example, let's say, for example, with PayHero Kenya. So PayHero Kenya, if you come and use PayHero Kenya, we're a very kind of like a very funny fintech. We don't hold people's money. So you'll realize, the right to realize most business were, they wanted their money to sit in their banks, their pay bills, their tills. So whatever the fintech that generally we build, or whatever the product that we build around that particular model. So we are not going to change like, oh, for us right now, moving forward, you have to come and withdraw your money to your till or to your bank. We're like, oh, when people pay, you will take that money directly from the user to your bank. So as a micro SME, which PayHero mostly deals with micro SMEs and SMEs in Kenya, that their behavior don't really change. And that is the goal, for example, of having an API. Yes. So you always hear the XYZ wrapper. And I think my main context is mostly fintech, because I think I've mostly worked in fintech, credit, and trading companies. So I've mostly dealt with money. But whatever the space that you are in, for example, this pretty much applies. If you're in agriculture, whatever that you are in. So you always hear the thing that, oh, you are an M-PESA wrapper, for example. So, and this is how most fintechs are, how most business probably takes. They take a particular API, then they serve that complexity to the user. So an API should be something that is way much more than, for example, what you call just serving the underlying API. Because again, what's the business value? An API should generally have, like we mentioned before, it should have the right abstractions to serve a user value without worrying about the underlying architecture, so that it provides for them accessibility, which means you are simplifying the layer. So the moment that you are doing an XYZ wrapper, it simply means that you took the API you've integrated, you took it how it is, and served it to the user the way it is. So you are not really an API in kind of like in a process, because you could have better still just served the previous API that you really had. So you've not really created an API, you created a wrapper around another API, for example, which of course may not really be a bad thing necessarily, but let's say from a business value, yeah, that does not really create that key thing, which is accessibility, which is the ease of use, or kind of like hiding the implementation or kind of like complexities within the previous API that had been generated, for example. So this is, I've kind of like done a very, very small thing, for example, on fintechs, which is, for example, how you'll mostly realize, I think if I open any random docs and you take a look, you're going to find this particular architecture, for example. So this is M-PESA. So let's say we have something called a Renha gateway. You're going to expose for each of those M-PESA. you have your payment gateway. So this side, you'll see on the right-hand side, we have the APIs on the right-hand side, which is the version 1 M-PESA banks, version 1 M-PESA shortcode, version 1 M-PESA number, version 1 CasaPay. So that now, this is a classical thing of what's called a wrapper, which is basically you've built an infrastructure around an API without actually creating the accessibility things that an API should give to simplify that particular communication between third-party systems and your system, for example. So yeah, that is kind of like one thing that you can have in terms of the wrapper architecture. So the approach kind of like the main integration kind of like approach with how to do so. This is probably how to do integration, API integration. So the problem is that this approach kind of like is around provider and actions, which has to be taken wherever it ties up. If M-PESA is down, you are down. Clients has to be aware of the providers available. For example, if let's say I want to do, let's say Airtel is kind of like wired through Remit Core, I have to understand that there's Remit Core under the hood, wherever the thing. So yeah, so those are kind of like the main things around the main kind of like one of the main things that there's no kind of like business utility value around that particular thing or around whatever the thing that you are building. Yes. So how best? So this is kind of like going to be one of the key things that even the key things that I've noted, especially with the rise of AI and everything else, is that you create something called a world space. So a world space is that there's a key defined thing so that because remember, AI is just, especially when you come to, let's say, if you're creating systems that AI is going to be very good at, for example, if you define a space of how things behave within your system, no matter how many providers you add, AI is kind of like going to have, let's say, for example, if you are integrating or let's say use AI internally for onboarding or use it for third parties to integrate, if there's a very clear defined way, for example, how you define user space within your system, then because remember the goal of AI is not always to, I can say, it's not always to kind of like to give you a perfect answer. It is kind of like to generalize whenever there is an unknown answer. For example, let's say you did a documentation on your system, let's say for developers, and you added a new provider that you've not yet trained that particular AI on. So if you train AI based on the XYZ wrapper, that will be a new wrapper that I don't know how to implement, for example. But if you give, for example, a defined user space in terms of how systems generally behave or how integrations, how you guys approach whatever the business problem that you are solving, then AI is able to generalize again based on that particular data and probably just see the contracts and how the contracts come in and come out. So this is one thing that, especially if you expose your documentations around AI, and we realized this thing when we were creating PayHero, because our PayHero developers portal is purely powered with, we have an agent that can help you do anything that you can do through PayHero APIs. And one of the key things that we noted was that having kind of like a well-defined user space really improved kind of like the output of when we went to Uganda, the AI is still able to support somebody great in Uganda. And we went to South Africa, it's still able to, without actually us going to retrain back the AI, because we had a defined user space with the proper contracts that explains, for example, how things should behave within our system, for example. So it's a very uncommon theme, and it's one thing that I mostly realized this because I come mostly from a data background. For example, if you come from a data background where this is very key, and you come to a web space where web is a bit crazy how people do web. So web is a very strange space. For example, if you come from let's say another context or another part of engineering, for example. So it's mostly kind of like a key thing, which is called, if you've ever done gaming development, you always hear something called, what's the world? What's the initial world? What's the final world? You always hear things called worlds. And the main thing is kind of like to define the bounds of how everything is supposed to behave based on a particular context. So that now you may not really know what the next step is, for example, but you're able to preempt what the next step really is. And it's mostly, the world is on the gaming side, the user space is mostly on the kernel development. And if you've ever heard of Linus, it's called Linus Traveled. If you're kind of like an IC contributor, or if you're a contributor in Linux, one of the main things you always mention is whatever you do, never break user space. And those are two things that for web development, they are kind of like thrown off the window. Yeah. So I think that's one of the best ways to approach sort of like integrations, especially for API integrations. And I'll probably explain towards the end as the reason why I'm going to give examples in terms of how, as at PayHero, probably we do follow this particular thing. So the key thing is that, so you have, instead of having a gateway, and I think I've done, like I mentioned, I was going to do it in the context of fintechs. Instead of having a gateway, you're going to have something called an orchestrator, for example. So um, I'm not really a computer science graduate, but I know there are two patterns that I've used pretty much. I've had to learn and use across the world, or across every job that I've done, be it on in data or in software. And that has been something called the strategy pattern and the factory pattern. So those are the main two patterns that, for example, I think if you are doing integration, especially the problem integration within Africa, which is one big thing, integration with Africa, is the segregation of payments. For example, you go to M-PESA, there's no kind of like a one standard. For example, if I'm in Europe, for example, I'm sure if I integrate Stripe, I can collect money across entire Europe. So I just have to worry about one integration system. Then I'm pretty much able to collect money from US. I'm able to collect money, let's say, or even if I do PayPal, it's just a matter of me choosing one bullet, and I know my payments is solved for me. If you come to Africa, in Kenya alone, you have to deal with Safaricom, you have to deal with Airtel, you'll have to deal with Tcash. You've not gone to Tanzania. You've not, when now you want to go to West, to Nigeria, it's even crazy because they are like every kind of like the microfinance banks and the MSBs and everything else that are always there. So if you come to the African context, is that integration is everything is kind of like scattered. So kind of like following an orchestrator approach doing integrations become very, very key, for example. And one of the key things that you generally have is that you deal with something called a switch. So you have something called a payment strategy. So that now you define the strategy becomes your world. So the strategy kind of like becomes how you define your world, which is which basically means for the value of having a payment orchestrator is that you define what the contracts look like, for example, within yourself, then you can sit around that thing. So it doesn't matter that you have M-PESA. Well, that is fine and good. It doesn't matter that you have CasaPay. It doesn't matter that you have Airtel Money, you have PesaLink, you have Yellow Card, whatever thing that you have, the contract that is exposed to the user in terms of the request and the response stays the same. So that becomes the value proposition. You define that particular world for yourself, for example. Yeah. So this is kind of like the main thing that we propose, which is kind of like to do, which is discovery. You can have within your micro gateway, you have a discovery API to discover that particular world. For example, you have your payments API, which you'll have one single API that it don't matter who you are serving, because based on discovery, somebody will know what can I do in the world at this particular point in time. So those are kind of, think of it in a game. When you're doing a game, when you're in a particular place, you know these are the only actions available to you based on what has happened before. So that becomes kind of like your discovery API. Then the payments API is just, the action is payment. So when the user is paying, it doesn't matter that they're paying through M-PESA, they're paying through CasaPay, they're paying through PesaLink. The action that they're doing, they're paying. So how do they pay? So that is what you serve them, for example, that you are just supposed to pay. There's no multiple APIs that, if you want to do M-PESA, there's M-PESA version 1. If you want to do, let's say, this thing, there's this version 2. If you want to do bank, we have a PesaLink. We have Yellow Card. The user don't have to know what Yellow Card and whatever the thing is. The discovery tells them what exists, for example. Then for them, they pay. It don't matter that they paid through M-PESA, they paid through Airtel Money. They just pay, for example. So that becomes kind of like the key thing in terms of how to approach, and especially within African context, this is something that is super, 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 super important, because building in Kenya alone is crazy, for example. Now, building for just even East Africa becomes way, way, much, 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 much crazier, for example. And remember, another thing probably to mention is that APIs by design are distributed. And think of this way. CasaPay is a different API. M-PESA is a different API. Airtel Money is a different API. PesaLink is a different API. Yellow Card is a different API. Now think, let's say you have banks, which individuals who want to get, let's say, IPNs from banks, for example. So let's say do standing order in bank, you have you have a check that has checked in the bank, and you also now have to go and integrate pretty much around 34 banks. So thinking from a monolithic approach when you're dealing with APIs, it may work in Europe, it may work in US, but in Kenya, for example, if you're starting to do integrations properly well, having kind of like this two-faced world, which either you have a monolith or you have a microservice, is something that generally you start to get problems pretty much in with, because you'll end up having a lot of providers if you're actually serving people within Kenya, which is even Kenya. Like I think PayHero, we have around 43 different integrations, for example, that is across banks, just in Kenya alone. And in South Africa, Nigeria, we have around 14, if I'm not wrong. So when you move across these things, you realize that by the virtue that you have your own payment gateway alone, you'll pretty much just have an individual service for handling your payments, for example. So yeah. So that's the integration architecture that pretty much I'm kind of proposing. So how to build APIs that orchestrate? So that is kind of like the question that we are doing. Yes, we want to build this thing that orchestrate, for example, but how do you build it, for example? So I think this is pretty much where we are getting pretty much to most of the things. I'm not much of a writer. I'm mostly a diagrammer. So I'm mostly an architect. So within data systems. So I mostly kind of like to talk through diagrams. So we have one that is called REST. So, and this is the question that I'm asking Fanny. Distributed monolith, which is kind of like a nudge to, I hear people always say distributed monolith, which is that you cannot distribute your application if you are not distributing your database also. That means a distributed monolith, but by design, for example. So, so for me or for us, most of the key that I've noted is that necessarily when you talk about microservices, I'm not really a fan of microservices. I'm not a fan of take authorization, put it in one service. Take authentication, put it in one service. Take user service, put it in one service. Take account service, put it in another service. So I'm not really I'm a fan of that particular kind of like design, which is the micro, going micro. But I'm more a fan of an SOA. So I think microservices is an implementation of service-oriented architecture, but it is one that I probably don't like that much. And the key thing is that you are being forced that for every something that is, you are being forced in a coupling corner or a decoupling corner, for example. So by design is that how can you divide your systems into, especially for us, across paid and across paid. I think even when we're building the data systems at AutoCheck, also across PayHero, for example, my very first question always is, especially as if you do API design, and again, understanding the users become the key number one. So what are your business use cases, for example? So what are your business use cases? That becomes the very first question that you ask yourself, for example, so that you know, for example, how to divide your system. So the key number one is, I do like the concept of, it is not really distributed monolith, but it is an SOA. Because remember, you want to scale. And I remember when we were talking with my co-founder, if I think Ronald, across most of the time, even when I was working at, when we generally were doing the system design for Moderna, the question was like, what's getting surprises that, and I think I'll probably quote what Ron told me about is that, Vincent, we are probably going not to have so many users right now. For example, why do we need a standalone auth, and why do we need a standalone payment gateway? For example, why don't we just take this thing? It was already, because we were writing something that exists in PHP. Why don't we take this thing and have it, let's say in Go, and find a way of, when we reach that particular point in time, then we move. But in API design or in systems, there's one thing, especially me, a person who's coming from an economics background, I know risk is never averted. You're never going to do avert risk. What simply you're going to do is that you are going to push that risk downwards, for example. So for myself, I'll think I have studied pretty much every single thing that I do ask myself, what are the key businesses? And I always end up to around two or three services. They're not really microservices, they are services. I'll have a core system, try centralize everything that involves logic. So what are the business layer? So my business layer, for any system that I build, that will always kind of like stay as a standalone system. So if, for example, if even until right now, the core business layer of in PayHero right now, we've graduated from the 3 services I created. We're around at 14 services, but the core business logic is still the same. The key thing that does all the business rules across the systems that we interact with. Then I'm going to have an authentication system. So even by the start is that if let's say, because remember authentication, there are 2 things. We have authorization and we have sort of like, we have authorization and we also have authentication. So if our authentication service may be down, but we are still able to kind of like do authorization within the system, for example. So dividing a system into a business unit is what I'm calling a distributed monolith. So that becomes kind of like one of the key things that if you want to develop APIs that pretty much scale, because remember, if you don't understand your business, if your business use case is probably a simple thing, let's say, for example, like just you're doing delivery, then, and you don't want to do authentication, then you can go do something called Clark. You can go do, as long as it's not a very tied thing, because again, that use case of having authentication within yourself, it depends on the nature of business that you do. So yes, a monolith may probably work for you for most of the time. But I do think that, I think because of the hate of microservices that much in terms of how people sell it out, people fear something called what I call distributed monolith, which is simply an SOA where you don't have to distribute a database. We pretty much still have the same database shared across the services that we do. We do proper pooling, whatever they can that do everything else. But the key thing that mentioned is that we do a distributed monolith. So how do you do that through communication by resource? Because remember, when we're dealing with services, even by design, you're going to have your front end somewhere else. So you already have a front end service somewhere else. So for APIs is communication. That is the key thing. So we have REST. What is REST? REST is communication by resource, which simply means that you know what resources exist, you know what to request. So I go users, I need user 1. So that becomes, I want users resources, I want 1 of those particular users. So for that, the key thing that, again, mistake that most people do, especially when you're doing communication by REST and also by gRPC, which is most of the case. So REST is the one that I think most people are used to, for most of the time, HTTP 1. The mistake that most people do is that you try code your business logic. And like I mentioned before, whether you want it or not, business logic is distributed, APIs is distributed by nature. So trying to kind of like trying to orchestrate your business logic within one single API becomes a problem. So how do you solve this thing? So there are things that exist that solve this problem. And one of the key things that solve this problem is something called business rules engine. So if you ever had something called Checkmable, you can use Checkmable. We have something called Go rules, for example, so that now you don't, if you're in the business of building APIs or any business logic, don't try distribute, don't try build your entire logic in code, for example. Distribute those APIs. So distribute any logic that you're building, distribute those things, then satisfy them based on a particular rules, for example. So you have a way which you've defined your pattern. So I think that is rule number 1, which is if you want to build APIs that scale properly well, you need to have a business rules engine where your business rules should not be code where everything exists in one function. You can have a monolith, but they should be sections of code that are not really orchestrated within your code. Don't concentrate something within your code, orchestrate something within a business rules engine. And I given to someone called Checkmable and one called, let's say, for example, Go rules. And let me give a use case example, for example. So let's say you are doing, somebody signing up. There are a chain of activities that probably pretty much is supposed to happen within your system. Let's say if somebody signs up, the very first thing that you need to do is probably call a KYC service, for example. So call a KYC service. This KYC service, there's a very high chance it is asynchronous. So for example, if I call, let's say I go and call SamSub is not going to give me a response immediately, for example. So then something has broken somewhere. So I'll have to wait for a callback, then read somewhere to know what the state is, then react. So by design, in KYC process, for example, how most people probably approach it is that it is a distributed system by nature. With the monolith the idea is that React wait on response on a webhook, try understand state, then react based on that particular state. You are managing two different things that are not aware of one another. For example, the request is asynchronous. Then the response is also asynchronous. Then you pretty much rely on DB to kind of like know what to do at any particular point in time. Well, that works, but at scale it has problems. That's why you have to reach out. And that's something I think we realize pretty much very quick at PayHero, which is that a KYC provider may wait until pretty much tomorrow to do something, for example. Over the weekend, sometimes Kenya government wamefunga servers and you have to wait, let's say, for example, until Monday. So by that nature, those are two things, but there's no visible way for a person to know this is where we are at, for example. This is what we are waiting for. So you end up having as you may have a monolith, but you have a segregated kind of like different states. You have the request side of things, you have the response and the webhook side of things. Now, when you have a business rules engine, for example, and what some of them is even an orchestrator, some of them is now very, very good. It's just you can request, all of these things have metadata. You can request, then you can have something called a human input or a provider input, for example, which waits. Then you know when you go at any point, let's say you ask Vincent submitted their KYC, they want to validate for biometrics, for example, which state are they in? When you come, you are able to know based on a distribute, kind of like on the business rule engine, that this is considered one big flow. It's not considered a segregated flow, for example, so that even asynchronously, you are waiting to kind of like, you're waiting for a response. That is something that is pretty much left for, they're left for microservices. But you can do that within a monolith, for example, by simply not trying to orchestrate your own logic around different functions. You may have different functions that are called that pretty much are being called by the orchestrator at any particular point in time within your monolith, for example. And to solve this thing is what people always called cloud functions or serverless functions, which was the serverless function supposed to solve this problem particularly. But we were trying to solve it when we already had a solution which people could pretty much do. Yes, you can also still solve this in serverless functions, which is instead of calling distributed APIs, you just have scripts that are called for a particular thing that exists within your monolith, for example. But of course, at scale, serverless functions are very, very painful to manage. Yes. So that is what I call distributed monolith. So the key thing that I've mentioned for that, and that's why I think I've even done it in bold, is that you have a business rules engine where so with the other side, you might have your client. Of course, it will call you API gateway, which might be again be a monolith. Then you may have kind of like your core business service application, for example, and I'm calling it application intentionally to show that it may be a monolith, for example, it's not really a service. Then you may have another service set up somewhere. Again, if in case you are handling payments, don't start with a monolith. You're pretty much going to cry within the soon. But of course, in a payment kind of like thing, where they're like crazy. If you're in Kenya, you're pretty much going to have around 80 providers to integrate. Having that in a monolith alone wouldn't make sense. So you may have another system that exists somewhere that you call through again a REST API, for example. Or even you may have your worker service that calls some things through API. Then that's what called your payment gateway application. Then of course you have your business rules engine that checks on what your core business application generally does, reacts based on different things. For example, is there possible fraud? What generally is going on or existing? So that is a most common pattern that people actually use. Yeah, it is the easiest to implement, for example. And for me, the catch is that you have a rules engine, because I think that is one mistake that pretty much I do a lot of consulting for startups, and they try understand why their code is way buggy. Is because when you try to build an orchestrator where you are writing either ifs or switch, you end up having very fat code bases. You may have even 1,000 lines of code trying to distribute logic across different providers, and you've built your own strategy pattern around it, for example, to understand how things to do. So you've ended up having a strategy pattern which should be based for routing, is being used to handle business logic. So instead of doing those particular things, the key thing, if you want to build a path that communicate thoroughly well, have a business rules engine. And also, again, in the context of if you use AI to program to give your services to users, you realize is that when the when the context or when something is disputed quite well and the knowledge around it is, the rules are there, like the business, when something is logical, for example, from the handset, then AI also becomes very good at kind of like traversing your system and helping in debugging and stuff like that. Because when you have a business rules engine, your very first instinct is not to code, is to define what the business rules are. Then have those kind of like coded out in your business rules engine tool. Then having proper inference to the AI really becomes good. So of course, I'm having kind of like I'm having a bias towards developers, for example. So even if you want people to with the AI to help debug very easily, is as opposed to writing business logic that is very, very within your code base and orchestration that's very, very brittle, having something kind of like coded out in business logic is really, really good, for example. So going out, again, this is still distributed monolith, for example, so communication by contracts. So number one is what I've basically done is we have one type of APIs that is the very, very common. We have something called RESTful APIs. So RESTful APIs, they are stateless and you really communicate through resources. So a resource means that if I want to use users one, if I want users, I'll get users. So saying users, I'll want users. If I want users, then stroke one, it means I want users resources of ID one. So that is one type of APIs that people create, which is RESTful APIs. They are mostly common for especially monolithic systems. And I think even if you're communicating with third-party systems, the very most common way we're going to communicate with those systems is RESTful APIs, for example. So there's API number two that I think also people use, but I don't really recommend it. That's why I think I've not done it for this, which is called, it has a lot of problems. For example, GraphQL, where you expose schemas and people can query those schemas directly. But I think those are reserved for people who have problems like Facebook, the scale of Facebook with 1 billion users, whatever, a minute, whatever the case. For kind of like individuals starting out or for startup, for most people, for around 99.99% of businesses, you can survive without GraphQL, for example. So I think communication by contracts, this is again another it's contracts is mostly gRPC. And the benefits of using gRPC, for example, especially if you're using service to service kind of like communication, for example, so internally, let's say you have your communication service, you have your authentication service, you have anything else. If they communicate through gRPC, they're way, way fast. Because remember, REST uses JSON. JSON is simply text, for example. So text is, they're very large, for example. So which means that, remember, this thing are still being sent, there are packets sent over the network. So if the size is big, of course, the speed at which you communicate between anything else over a network, of course, it becomes slow. So that's what gRPC pretty much solves, especially for inter-service, for example. So if you just have some internal services where it's not really exposed to the users, you don't have to expose your contracts. These services communicate through contracts, for example. So let's say your payment gateway is talking to your business rules engine and you want to understand whatever is going on, they can simply communicate through gRPC. So it's purely protobuf. So they communicate in protos, which means that they're binary. So they're very, very small. They're very lightweight. So the speed of communication over network becomes very, very fast. And it also provides way more other better, I believe, especially for inter-service, where you are able to stream. So bidirectional streaming, directional streaming where only one side streams, either the client or the server. So instead of kind of like building a broadcast between systems, for example, or kind of like opening, I believe, WebSockets between different services, if in case you are just communicating within your services, then so like gRPC gives you way, way a lot, where you can, instead of sending one big image, let's say from your API gateway to your authentication to upload it, for example, to upload somebody's profile, you can take that image, break it into chunks, send it as chunks, stream it as chunks. The API gateway, of course, will take it, the auth service will take it, reconstruct it, upload it to an S3 bucket, whatever the case. So that is what communication by contracts is. So communication by contracts, again, is good. The benefit also gives you is that you can build your clients in any language. So you can build your client in Golang, Python, PHP. So it gives away which, for example, let's say, for example, you are building let's say your servers, for example. And I think this is one use case for us, is that our main applications are mostly into two languages, which is we use Scala And we use also Golang on most of the things that pretty much we do at PayHero. I think even at Paid. But you may need to do AI stuff, for example. And Python has really, really good APIs for interacting with the AI and doing stuff like that. Then with the gRPC, you're able to like, what? Of course, we'll take the data, we'll do the data processing in Go or in Scala, we'll take those things over to Python to do now the actual kind of like machine learning stuff, AI level stuff, and not worry about, let's say, the speed of things, because at that particular point, it's probably just doing distillation, you're doing training, all those stuff. So gRPC gives you that easier way, which you have flexibility to kind of like integrate with any language within your server. So it doesn't tie you, for example. So it's built in terms of remote procedure call if you ever communicate with RPC, but the limit of remote procedure call is remote procedure call is simply you can call a function remotely. So as long as you communicate within, let's say, within one HTTP kind of like server, then you are able to call from one service, you're able to call a function that exists in another service, as long as the communication wire is the same. But the problem with the RPC protocol is that everything has to be one language, for example. So that's just the only problem with it. So with here, of course, you'll have something called client. So again, it's microservice in nature, or kind of microservice in nature. So you might have, let's say, your profile client. You may have, let's say, your payment client. Within the server, you'll have your server one can be, let's say, for authentication. So it's kind of like trying to divide your application into, yes, everything may be a monolith, but splitting your application again into distributed nature. So that's why I call it distributed monolith, for example. And each of them, the client may be down. For example, in our particular server, client A may be down, but you are still able to use something in client B within, let's say, your distributed monolith application that you're doing. Yes. Then finally is, I think, the key thing that I recommend for most people, which is there's a different way to do API. So this is gRPC. So I've said 3 APIs. We have RESTful APIs, which is stateless, for example. We have gRPC APIs. So REST communicates through text, which is JavaScript object notation. That's what JSON is. So it's basically as object notation through text. So of course they're bigger. We have gRPC, which of course is just RPC remote procedure call, but Google created their own API around it. And you can pretty much communicate through binary protobufs, for example. So it's faster, it's lightweight. It uses HTTP2, for example, as REST using HTTP1. So again, it uses a faster protocol, for example. So it's very, very good for inter-service. So if you have services that you're not exposing to users externally, and you have, let's say, 1 or 2 services you want to communicate with, the best way to communicate through them, of course, is gRPC. And it also gives you the leeway to kind of like work with multiple languages, for example. So you're not really tied down to a particular language. We've also talked about GraphQL, which is, again, it simply exposes kind of like some schema that individuals you can give you. It's a query language which the UI people or your users are able to query those any data that exists behind it. Is like you've exposed for them SQL, for example. So for that, of course, you want to go into it, for example. But there's a funny thing that again is coming up, which is, and it's mostly by nuts. And it's the one that I think we use mostly at PayHero, which is a microservice, or what people call SOS. So can we have, again, this meant to be funny, which is, again, it's a monolith. It's kind of like a monolith, but it is macro, you can say that. So the main goal of this another API pattern is communication by messaging. And if you ever used any of these, the option 1, gRPC and REST, you're going to need an API gateway. If you need an API gateway, you know the things that you're going to do: logging, authorization, authentication, everything that generally comes with all of those particular things, being that by nature, all of those things are not built in, for example. So what I meant by microservice is that when you use NAT, for example, so it is communication by messaging. So, and again, you can see there's something I've called pub/sub, which is NAT follows something called a pub/sub approach of doing things, for example, but it follows in a very funny way, which is that it is pub/sub, but it's not asynchronous. It can be asynchronous, but you can request and get back a response. So it gives the normal request response thing. So it's not really a broker per se, where you send somebody and you wait in another channel for you to wait for kind of like a consumer's done the things to give you back a message. So this is the one that I think I love the most, especially Nuts is, first of all, it's written in Golang. It's very, very simple. It allows you to do service discovery. It allows you to do logging. It gives you pretty much every single thing that API gateway can give you in a very simple, lightweight package. And you can even take your monolith, for example, and call it a microservice, divide it into components, and let each of those components communicate through queues, because communicating through queues is really, really fast. But it gives you PubSub with the ability to respond. So when a subscriber takes something, they're able back to respond. And if you need to scale any service that you're doing just have 4 subscribers, then they'll find a way how they do those particular jobs in them. And there is a tool by them called Micro Gateway, which is a very awesome tool, especially for doing communication by messaging. Especially as it's a very, very new and niche protocol. For example, it's mostly common if you use Golang, and it is purely what pretty much, if you go to pretty much auto check, the data systems within auto check. If you come to PayHero, if you go to PayHQ, all gateways that we use under the hood, they're all powered by this type of communication, which is communication by messaging. Yeah. So I think that is my final one, for example. So I think how do you kind of one of the most important things when I say transaction security, this is pretty much anything that happens in a system. If you're dealing with an OLTP system, even that open a system is kind of it's transactional. So it's called is it OLTP? OLTP, yes, OLTP. So OLTP is a transactional system, which is like your database where you kind of serve your business locations in. So one of the key things that people right now I think is starting to be common, which is use encryptions. That is both HMAC to know if somebody has modified a signature, they may have gotten your encryption keys right, but if they've not gotten the signature right, then things fail, for example. So you can always communicate any service communication you're doing between your front end, your back end to back end services. Always make sure that you use encryptions. And I love using IS and HMAC encryptions. Again, never try to code your business rules engine down. So let's say to monitor any fraudulent activities within the system. So we always use business rules engine. So we have Checkmable, we have Go rules, and we also have orchestrators that are not really deep kind of like business rules engine, but you can code rules in them. So those are things like OCS conductor or conductor, the conductor it was a tool by Netflix. We also have Temporal, for example, which again, the end goal of this thing is that make sure you are trying to segregate your business, because by design, when you're dealing with the APIs, they are orchestrated. They are kind of like microservices, because every single API is its own rule. So if you may be having your monolith, like everything is one big monolith, but how you interface with those particular functions, don't try to interface the functions with you yourself, for example. So that is the case. So yeah, so a sample architecture. So I think this is kind of like a use case, kind of like one thing pretty much to do, and I'm pretty much doing a fintech for that, which is trying to kind of like map up, especially for the key thing that I'm trying to map up for this is what you can say, it's kind of like a monolith, but it's trying to show, for example, how you can divide the monolith and put those into small services. So of course, when you do a pay-in or do a payout, you'll do things, you'll verify the signature. Of course, you'll have your rate limiting. Then now you see, you don't see this thing, you don't try to take all of this thing, like what exists here, the upper part of it. This one, most people will have it as a service, as a code layer. So let's say we have a ledger service, which is, let's say if you're in fintech, ledger service becomes very, very important. So the very first thing that may happen, you may have, this thing is one service, but you may have a BRE, which is verified transactional request, for example. And this is now a business rules engine, which will check different things, check the limit, check the amount, the user historical amount, for example, what they've received, check all of these things that is trying to understand, for example, okay, how does this request look like? This can be a module, for example, that is distributed. It exists and around something like, let's say, for example, like BRE, behind nuts, anything that requests that can give something called request response. Then that thing goes to the next step, which is create a ledger transaction. Once that has been done, create a ledger entries, compute the balances from entries, move the ledger into account balances, for example, verify the ledger transaction, send the request to the provider, which is, it's missing API gateway here. I'm not really a good drawer, so you could have an API gateway there. Then respond back to the provider. So you can see this ledger service, the entirety of this service is that it can be under something called, they are all kind of like, you can call them actions or steps. If you're using temporal, they're called steps. If you're using OCS, they're called actions. Whatever thing that the tool you're using to kind of like do your business rules engine, then it will wait. It will know this thing is still pending. It's awaiting an event. Then it will get an event again. Then say settle transaction, settle ledger entries, recalculate account balances. And this becomes, yes, this may be your monolith. Like you can see everything is one big monolith that I've had as a simple use case, but we distribute that monolith, for example. So that is the key thing for me, which is you can take your monolith with the right tools and you can distribute that monolith, for example. You don't have to make sure that every single thing is functions and codes. Some of the things can be something called workflows, where instead of thinking of something as a ledger service, for example, like I've named it there, or a ledger application, like I've named it there, I can call it a ledger workflow. Then in a workflow, everything is a step that feeds off the other. If a workflow is not complete, you'll see if it is not complete. If it has failed, I can come and I don't have to go to code to see what happened every single step. I can go to the workflow and understand where did something fail. For example, what was the output? Because for even if I'm debugging code, I may not know if all of this thing is a code level layer, like nimeandika a service, service A, service B, service 3, service D. Unless I'm going to the logs and I'm logging the output of everything, there's not an easy way for me to know, okay, something may be buggy. What did create ledger transaction output, for example? I may have to go to logs and I may really have a very noisy logger for me to identify that particular thing. But if I come to workflow, these things are considered steps, and each and every single step, there's an input, there's an output, there's an input, there's an output. And I'll demo a small workflow, for example, at the end so that we see how that generally looks like, for example, how workflows look like. So then you change from having fearing microservices, really. You are not really implementing microservices, but you're simply taking our thinking of our application from a monolithic approach, for example, to kind of like a service level approach, even though things are in the same application. Then what this simply means when you check this particular architecture, if let's say we grow, and right now having things, we want ability to do BRE independent of any other system, it's easier to pull off, let's say, the business rules engine and have it now as an independent microservice, for example. We can think, oh, we need to have ledger as a dependent service. We can take a list of the action that happens, let's say, within the different actions in ledger that can have, let's say, we'll have the ledger transactional service and entry service, and have, let's say, the ledger balances service, for example, so that we can have a service that helps kind of like handling just the ledger transactions and journals, and also have another service, let's say, for mostly doing management of balances, the recomputes, the reinsertions, the reconciliations. So that becomes a very, very easier to do, as opposed to, let's say, if we took this thing and we can do it without hurting the code, because in code, these things are not connected. They are very independent. They're like independent modules of themselves, for example. So you are distributing your monolith, in short. So you have independent modules of your code within the cell. Then you connect them through workflows. So it means that even if I take this out and move it somewhere else, the workflow only cares about the input and the output. You don't care where that thing lives, for example. You just need to point it. This is what you need to call. This is what you will get back as a response, for example. Yes. So I think this is pretty much it. And in terms of the how do I say, the diagramming side of things, and also kind of like something that I need to kind of like mention as we go, as we go on with this, is that modularizing kind of like business, because remember, when you modularization pretty much is documentation in itself, for example, in that when somebody comes, they're able to get context easily. So if somebody comes and reads a workflow, for example, doing a workflow, especially in this modern age of dealing with AI, doing a workflow is a way much better way than trying to code a very complex system. Because remember, when AI comes to a very complex, because this is a very, very complex workflow. And if people do this with code, like I've seen fintechs who people do this thing with code, for example, it becomes where if AI comes, for example, the AI is very hard for them to get context, for example, so they start hallucinating. For using distributed monoliths in this particular case, where you have kind of like different modules, they can, oh, this module is for this thing, this module is for this. So it's very, very easy for them to kind of like get context without doing compacting very, very quick. So if in case you're doing assisted or AI assisted development, for example, with your code base, even following this approach makes it a bit faster for you to iterate, for example, a bit faster for you to onboard people, because it becomes quite easier for you to, or AI will use less tokens, I can say less tokens, to kind of like get context of what the system generally is. Yeah, so I guess that is that. So demo time. So I think I'll probably do a demo. I don't know how much time I've left, but I think I'll try to do a demo quick before before. So I'll pretty much just scour through things very fast and pretty much do the Q&A and demo side of things. So okay. So I did create an API to do most of these two things, for example. Okay, so let me bring, okay. Yep. Okay. Okay, let me bring in the NAT server. Okay. Okay, perfect, great. So let me zoom in. So what we have here is we have two applications again so that we can just demo, for example, what we're working. So we have two applications. I've got two applications. So we have one called Conveyor, which is Conveyor is Spanish for communication, for example. And I've demoed two things. So this one uses mostly, so I've demoed two things. I've demoed how you can distribute your monolith, for example. So within this application, what we have is that this is a monolith. You can think of it as a monolith. And what we have in this monolith is that so what this application does, it gives you, so you can think of it like a templating system, where, for example, you need to send like if you build applications, you may need a way to send SMS, for example. So sending SMS, sending, let's say, sending SMS, not necessarily, I think email is, I think, is the best use cases. So what the system builds is a simple service that simply, when you give it some data, it gives you back a response of the templates. So a template is an email template that has HTML, CSS, whatever thing that exists in that. So again, I like using hexagonal architecture whenever I'm doing my system. Again, it's kind of like a child of, and again, if you see, for example, this is what I'm doing for AI. So if an AI comes to my system, again, this becomes, especially if you're in Python, kind of like whatever the tool you use, for example, to program, at this time, AI love these things, for example. So I think this is a PIP 8 documentation style. So I love sort of like this mode of communication, so that when they come, they're trying to pass your file to the system, it's quite easier for them to know even how to test, how to run, how to do everything else. So you want to do all those things. So yeah. So if you come here, I'll have my services. So there's nothing really crazy. So I think you'll have my templates, which are the different templates. I think I took some few templates that we do, let's say, for example, for PayHero, which is, for example, just quite a few things that we do generally at PayHero. Just sample them, and I'm having them as Ginger templates. So the key thing is that we have this template. Let's say we have somebody and a service, we want to send an email, but they don't know what to send. So instead of them worrying about the login template or implementing it or copying it around, we can have something sitting in our templates engine, for example. And so this becomes our templates engine. You can send the data that is needed to this templates engine. This engine gives you back a well-formatted HTML and CSS so that you know how now to react to those particular things. If you need to build something to pass it, to have it an email. So that's basically what this does. It's a very simple to ask that. So if you come to services, you're going to have something called notification service that again, that PIP, kind of like the PIP 8 notification, kind of like things that we do, documenting everything. I think that's again another key that now with this age, because AI is not going anywhere. AI is here to stay. Whether you think of it as a tool or you think that it will replace programmers, for example. But whether you think it's a tool, it is something that is not going anywhere. So making sure that any person who want to come to the system, be it through AI, be it through anything else, they're able to understand without giving AI any chance to hallucinate, for example. So yeah, so you'll notice that I like doing that, for example, across all my services. So what this does is just notification service, for example. So it's the one that goes through the different, so it will send the notification, for example, to getting through different channels, trying to send, if I want to send the email, want to send SMS, whatever they want to do, it will kind of like send all those notifications, for example. So yeah. Then you have the template service, which is what we're going to test again. So it will have kind of like the different, this is the thing that passes, just a simple class that passes kind of like the templates and is able to give back the user, for example, whatever they're getting the data that they've passed. Because again, this is a templating system. Then you have the templates. Then you have our worker. So our workers are you can think of them as the consumers, for example. So they are consumers that now exist on subscribers. So that the subscriber that exists mostly on the NAT side of things, and they're able to kind of like listen and do a request response, kind of like to different things. And you can see how things happen. You just do an endpoint. So the tool that we are using for this is a tool called, so that I think I can just share it. Okay, let me bring my other screen here. Yeah, so so this is NATS. It's a tool called NATS. This is what I'm using, NATS. And yeah, you can see we are at level 2. So so there. Yeah, so just NATS. Of course, I'll share the resources about it, how to read about it. So it's a tool that I like quite a lot. Because those are just innate. Then of course we have the configs that help us to set up NATs, for example. These are fast API server, for example. Then of course our DTOs, which is our data transfer objects, for example, because again, we are communicating through data. So we'll have our data transfer objects that's there, defining the different notification classes that we have written on backend. And of course, that is our main. And again, the common theme that you've seen how I document, or how this is mostly not, yeah, it is for humans, but I document it in a way that even AI is if they come, they don't have to hallucinate across our systems a lot. So what I'm going to do is start this. What I'm going to do is start this up. Okay. Yeah, so let me start that at put 8,000. And if I come here, so again, documentation again becomes crucial. So let me copy that. Okay, I'm bringing up my browser this other side. Yeah, so so we have reload. So we have 3 things that we have. So this is of course our documentation. So I just called Fast API gives you this by default. So again, that's the reason probably why I love it. So you have a health endpoint to know whether things are going out well. So that's our health endpoint 4. We have our render, which is again, you can see how you can, so the render builder that sort of like brings most of those things out, for example. And we also have notifications, which you can see. So let me come to render and let me try it out. So I can say I want to log in OTP, for example, and I can execute. Yes. And there. So you see the response that is here. I've passed in some data. So then I'm able to get the different things. Then I'm able to get the body. I'm able to get the body. For example, I was unable to build the CSS side of things, but for example, I think this one, if the CSS actually exists within the body. So yeah, but you can also have it return. So of course, I never worked deep on it because I could have had, but you get things that you got originally. So you get what has been rendered for you so that you're able to get all of these things out, for example. And I think if I wanted to build for email, so this is for SMS. So you get if you want to send for SMS, you get the one for SMS there, for example. And you see the exact SMS that you can exist. So as somebody who has the body, so if I'm sending SMS, I know the tool, I know the channel, I know the notification type, I know the original data that I got, for example. That's the phone number. Then, for example, you can even add a parser to provider so that now that system already knows this thing. So there's no need for anybody to build that logic for themselves. They can kind of like write a very simple parser to kind of like just know, oh, this provider, this is the message, this is the phone number, send that. And you can see the channel for email. Then also that exists. The title is there, the tool, the channel is email, the body. You can see the entire body that exists there. And you can also see the original data and the notification type, for example. So that is login OTP. We can also have as many as we want. So this is now the simple. So what has existed here is that when this is called, this is ideally not, it is an API that exists that calls. We have our service, but we divided our service into two. We have a notification service. So the key thing is that, these two services. So this service, the notification service, and that is trying to orchestrate and tell us what exists, and the template service that actually gives us back the template, for example, we are not calling that through code. So yes, we have a monolith that exists here, but this service and this service are calling themselves through the NATs, through the NAT server. So, and NAT service, and that we embed that within our application. So it runs within the application itself, within NAT. So you can even embed NAT within a monolith. So now the key thing is that we can have a request response where I'm saying, I don't want to have another third service to have a business logic to do for me all of these things. For example, I can do my business logic around NAT, and you can choose as many things you want to do business logic on. So that now business logic, this service, the notification service, which is the thing that is called when you call render, calls the template service, not through code. It responds back to template service, and template service gives back the user the response, for example. So that is the one thing that we're solving, which is now communication by messaging, for example, which is another thing. Again, it's very good for inter-service communication, and it makes me easy in a very, because it's as fast as just having RabbitMQ in your system, for example. Actually, way much more faster, because again, it's in Go. So it's like you've added an invisible layer to help you orchestrate between your different services, for example. So yeah, so I think that is that for that. Again, I'll share this code. I think I'll share this code, then we'll share you'll share the source code, of course, later for kind of like communication stuff. And I can also do this thing with let me come here. Okay, let me not do this thing. What I can also do is, okay, I can do make. Yeah, I can also do make, render, sign up. And if I come to make file, for example, and I say render sign up, okay, where is script? Yep. So what has happened here is that I've simply gone to script. So I have touched those forever. Yes. This is now a NAT server. So I'm getting the same thing. So now this is now without less example. So I've implemented my own client, for example. So this is the funny thing is that even without gRPC, which of course we're going to see gRPC, the next step of how to do gRPC inter-service communication, but I'm even communicating. I have another file, for example, which is of course another script, which is this one. So this script, it's simply trying to send some data. It's a bash script, of course. And I've written this with AI. I've not written this with my own hands, whatever the case. But it's simply kind of bash that is trying to have a NATS client, for example, and call our NATS API and generally respond back. And you can see how it's responding back. So which basically shows that, for example, even there are two things we can do. We can even communicate with the NATs from now different services, for example, as opposed to just within the service itself. So then the second part, I think that part is running. The second part is now something I'm calling micro gateway. So now micro gateway is not purely gRPC. So where gRPC, like I mentioned, is something that's based on contracts. So you define as per REST where you give people URLs, gRPC, you give people the contract. So in REST APIs, unasikianga watu say, give me the endpoint. So those are just the direction of where the resources are. For gRPC, you don't say, give me an endpoint, you give me the contracts, for example. And the contract can be, I think if I come here to Proto, yeah, again, same thing. I've simply just done documenting all of those things. So if I come to Proto, I have my messages at the top and I have my services at the bottom. So these are my messages, for example. So this is, if in case I'm doing gRPC service from a person to person, this is basically what I give them. So this is what I give them. I give them what tool the API will take, so they know this is the actual contract. Then I also give them the message that the server that they can call. So this service will become a server, so they can call that from their client, for example. So as long as I've given them this thing, they're able to generate the client code, and they're able to call my service directly as long as I tell them this is the domain. This is kind of like the network where to call to discover my service. This is generally where we get my services from. So then when you generate, you get the protobuf, which you can generate the protobuf in any language. So I've generated them into Golang, for example. So don't worry much about that. Then I have the implementation. So if I come here, I have the nuts client, which is now the funny thing is that I want to call nuts client from this other service. So we can assume this is a different deployed service that exists somewhere else, for example. And I can discover the nuts client running on, I can communicate through, I can call something that as long as we have our nuts server that is being deployed to, I can call through queues, because remember nuts is a pub sub service. I'm able to call that particular nuts server and I'll get back a response from a different service. And I've written the client in Golang. Remember the service written in Python, for example. Now the client that I'm going to call for that particular server is Golang, and I can call those particular endpoints, for example, directly from here. So if I come here, okay. Okay, so yeah. Okay, so may go run CMD. Oh, it's already new, so it seems I've already started that out. So if I make render, sorry, let me just do this again. Make render type sign up. Yes. Yeah. So yeah, you can see. So from this side, what I've done is from Golang side of things, for example, I've been able to do a gRPC request, which I think if I come here, you'll see the client code, basically. So this is the client code, which is, again, don't worry about it. We'll publish this thing, for example. And I'm able to call the nuts gateway, which exists in Python, for example, and I'm getting a request response kind of like things. So even you can even see that while you can start off this thing with, especially for building to scale and for all of this thing that still exists without changing your tooling, because again, the key thing that most people most probably fall into is that you start with a very, very bad tooling. Then you're like, okay, we just need to get this thing to the market. While it is good to kind of like validate, but once you've done your validation stage and now you have, because remember when you're talking on to build something that actually scale, is that you don't want to go 3 years down the line and you do a complete 360. So how you choose your tooling becomes a very, very important aspect, for example, in terms of what will change at what stage of the time will those particular changes generally come about. So the main important thing is that you want to absorb those risks as much as possible. Because again, if you have 5 clients and you think you are going to scale, or you are building for scale at 5 clients or at 50 clients, you always have the niche like your 2 clients want to use your microservice, for example. But remember, well, that is really good, like true. Your 2 clients don't need your microservice, for example, the case. But remember, you can build your system in a way that moving to a point which you are able to scale individual parts of your application becomes way easier. So like I've given this example where I'm assuming, for example, before we had our API existing, the API was in the first API. Like if you came here, this API that we had here, it existed within this particular system. So it's with this system, and you're able to call that first API. It will communicate with the other services through nuts, for example, through nuts, whatever the thing, through the nut server, for example, and they're able to do kind of like a request response, kind of like exchange over over some exchanges, for example, and to get that particular out. Now, let's assume you're like, you know what, Python is way too slow for my API gateway. I need something very fast to handle my API gateway. And that is now the second particular demo that we've done here, which is you can abstract that out and now have it like, you know what, it's a very simple thing. I'm just going to have something in my gRPC sort of like thing, or in Go, for example. I love that as something I'm calling my micro gateway, for example, and people can communicate with it. It's faster, it's whatever the thing that happens within it. And your backend still stays in your pattern or anything that, and abstracting that becomes a way easier thing because you are simply abstracting a part of it without actually affecting the entire application that you had there or changing anything drastically, because I've not had to rewrite my services, for example, to cater for my change of moving my API or moving my contract from that Python stage or to another thing. Because basically what I've done is I've moved the notification service from Python to Go, but I've not had to touch anything else. I've not had to move any code. I've not had to do anything. I've simply just been able, okay, I'll take the notification service. I'm going to write this thing into Go, probably call it micro gateway, and the communication still stay the same. Even the previous thing that existed still works the way it was working before, because I've not really touched anything, because the initial thought was that I'll just have my services because I know they are very different. Notification and my render package is very, very different. For example, they handle very different use cases. Notification is supposed to construct, notify, get some details, whatever the thing. The render is supposed to just give me back the HTML and the CSS, for example. So now those two things, they can communicate asynchronously or over a wire that gives independence of them without me trying to orchestrate that through code. So yeah, so I guess that is pretty much it from my side, for example. And yeah, so I think I've tried to make sure that I stop, don't take more than 2 hours. So I guess that is all from me in terms of the demo today, from going mostly from, I believe, from just the theoretical part of things, how to approach systems, how to think about systems. And I think now the second part of the demo. And as we go, pretty much as I leave pretty much here is that there's always a concept, a misconception pretty much is that people always confuse simple with easy, for example. So people always consume, if you go through application, people always consume simple with easy. Remember, easy is something that you are used to. So even as you approach systems, easy is something that we are used to. Does not necessarily mean simplicity. And remember, serving simplicity, or from an API perspective, serving simplicity may really be a very, very complex kind of like architecture. So the simplicity of something can have the complexity of a particular architecture. So even as you think, as you build systems out there, as you grow from this particular thing, is that if you're going to scale, if you're an engineer, if you're a founder, for example, I have mostly my co-founders that I work with, for them, they're move fast, break things, stuff like that. If in case you're an engineer, the key thing happens that what is the cost? So you always have to view things in terms of cost. So what is the cost of changing something while you are having 400 transactions, let's say a minute, for example? What's the cost of changing something? What's the cost of serving a new experience to users where you are that particular big, for example? Can you afford it at that point? Or what is the cost, for example, if you have 10, 20 users using a system, but you are seeing a scale which you're like, you know what, in the next 1 year, based on how we're seeing our growth, we're going to scale. So don't necessarily go and build microservices. I'm not really a fan of them, but build distributed monoliths, for example, so that now when you need to plug something out from your system, it's very easy. When you need to move something from, let's say, Python to Go, it's a very, very easy thing. And that's an experience that I had, because I think PayHero existed since 2019 for most of the part, and it was mostly in PHP. And the cost of a migration from PHP to Golang and Scala was one of the most gruesome things that ever went in my life. We almost lost every single client we had. We almost had to start from scratch. And that's the thing I thought to myself, you don't necessarily need to have to start with a rigid monolith. You can start with using tools that are free, really. They're open source. They don't really add a lot of weight to what you do, but they allow you to think from your system from the point which, for example, from a decoupling standpoint, which you see your services as business lines. For example, you see authentication, that's authentication. It has nothing to do with payments. Payments, that's payment. It has nothing to do with KYC. It has nothing to do with somebody's amount they've transacted, for example. That is a different tool engine. They have nothing to do with somebody that they have M-PESA or they have something else. So the best way to think about APIs, especially in an African context where, yeah, in Kenya alone, you'll do 80 APIs, for example, is think of your system in terms of the business lines that you're dealing with, for example. And when you think that way, you are setting yourself for success. You can have everything in a monolith, for example, but that simply means that one point which you need to move your notification service because now, or your authentication service, because now a lot of systems are using it. You've had some third-party systems, you've had some third-party users who want to use your white label, whatever the case. It makes easier. You can simply plug it and have it individually, for example, without breaking any flow within your system, because you thought about seeing your logic as a means of orchestration, as opposed, for example, kind of like to a means of kind of having a business logic that glues them together. And I guess that is all from me. And I'll pass it over to Douglas. Thank you so much for the session. Thank you for being patient. And yes, let's build APIs for Africa.
Wow. Wow. Thank you so much, Vincent. I know today wasn't a walk in the park for first timers, but as you say, there's a difference between easy and simple. So it's up to us to choose. I really appreciate the very many insights you had, Vincent. You're a very smart guy and you're very intelligent. You know how to deliver high level content in a simple manner. And even for those of us who are interacting with APIs for the first time, at least they can get a gist. I also really acknowledge the fact that you're able to break down the architectures for APIs. And anyone who is watching, if you're still on the live chat, you can just appreciate Vincent with the virtual claps on the live chat. I really know he took time to prepare for this. The time has been worth it. I wouldn't even want to end the session today, but unfortunately we have to. Even though you've really taken your time to expand on these particular topics on APIs and from a very senior kind of background and the level and the manner in which you approached it, I really think even for the junior developers who are here or the mid-level, they've been able to pick a few things. Also, Vincent, as you take a breather, there are a number of reactions from YouTube. Yeah, not quite many. Yeah, I can see you have your claps there. Someone is saying fire. We have someone by the name Vincent Gishira. He's saying he has, I hope you know him because he's saying that he has worked with you and you once killed two stones with one bird. I know that must have been a technical problem. No wonder he has interchanged those things. Of course, you know what he means by that. And he's acknowledging that you are a senior engineer by yourself. And yeah, Vincent, so that feedback is captured just to also appreciate our session speaker today, that you've really done a lot in the fintech space, and that must be acknowledged. Lina Muhonja was, actually that's a question. If the payment is abstracted, how does it know I want to use Yellow Card wallet and not PesaLink wallet? I don't know the context of that question, but I think you can be able to respond. Then, okay.
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 Okay. Sorry.
Okay, then I think I was trying to also understand what Lina was saying about what's the future of payment orchestration with the emergence of blockchain, which is slowly getting into the market. You can also maybe respond with that. You have very many clubs here. I don't know how possibly you can develop an API to pull the clubs from YouTube and possibly have them on your end. Yeah, someone is saying they came in late. They came in late, but thanks for sharing. Which means even though they were late, but they were still able to get quite a number of things. We really appreciate the clubs from Moses, Cynthia, Kenya Daima. Okay, yeah, the session is live on YouTube, Moses, and you can rewatch it later. Actually, for those who joined when the session was already on, you can rewatch this of course on this channel. You can rewatch it as many times as you want to. But also, if there's a concept you missed, you can go back. Especially when we started on practicals, I realized, wow, that was quite a thing. Seeing maybe if you're not familiar with the working with the terminal, the shell commands, yeah, you can go rewatch that. So, Vincent, I don't know if you can respond to what Lina had asked about payment orchestration with the emergence of blockchain, and also after you've abstracted, of course, your payments. How does someone know, or rather, how does it the code? How does it know whether someone wants to do yellow card or PESA link? Maybe I'll give you a chance to respond to that first. Then you can. I'll also read out to you some of the questions that had been raised by the audience. Yeah. So Vincent.
Okay, thank you. So I think it's also good to know that first of all that Gishira is here. I think that is that a guy we've suffered with in this particular space. Yeah, thanks Gishira for coming in. So I think for when kind of like you build an abstraction, and again, I think I'll pretty much point out abstractions are very, very dangerous things if you don't do them right. They become complex instead of simplifying, kind of like any interface that you're trying to interact with. But if let's say you do abstractions, especially when you're talking about the world, let me give probably a simple example. So let's say the rules that you have, let's say for myself, or let's say for Douglas, is that you have, let's say, the probably a pricing of less than 2%. So those are kind of like the characteristics that you give, because remember, you've orchestrated, you're not really trying to show someone to use yellow card. You are showing that somebody has these characteristics, then what do you serve them best, for example. So let's say the system find that Douglas is supposed to be charged less than 2%. They want to send money to South Africa, and let's say they want to send 900,000 to South Africa. So let's say in South Africa, we have two providers. So let's say we have yellow card in South Africa, and we also have how is it called? On Afrique in South Africa. But remember, you've given characteristics to the system. Then the business rule engine will sort of like take that thing and realize which provider that now, because remember, you've abstracted this thing to the user, which provider is, first of all, is even up. If let's say on Afrique is not up, then by default, automatically, don't serve them on Afrique. Give them, let's say, give them yellow card. If in case on Afrique and yellow card is up, then based on those rules, which of those two providers, for example, satisfies that particular rule, then you realize that, oh, on Afrique charges 3.5% to do transactions South Africa. And then you're like, oh, then definitely we're going to give them yellow card, because on Afrique already kind of like does not meet one of the rules. That's why it's called business rules engine, which just defines the characteristics of the player, which is the rules engine is the world. So which has rules, then it defines what the player is, then it serves the player based on the characteristics of the player. Another sample or another example can be like, for example, on Afrique needs the user to provide their ID. Let's say the ID number when they want to kind of like do any collections, for example, from South Africa. So they need to identify the ID number, or let's say when they do payouts to South Africa. then you realize that, oh, Africa needs that. But now automatically the user has been eliminated. The rules engine will eliminate this, like, oh, this user has not provided the ID, so we won't even consider on Africa. We'll can reject. What do yellow card need? Okay, are most of those rules met by this user? Serves that particular thing. So that your rules engine defines the things that the provider actually requires, for example, and the things that the user actually needs. If there is a tie, then of course you can use a sliding window. Now that is because you can find where the things, they are generally ties, like they come and they're ties. Then use the sliding window. So the sliding window is that now you can pick, or you can use round robin, whatever the analogy that you can find when they are similar characteristics. But now you can say, when the first user comes, give them yellow card. If the second user comes and the same characteristic, you already picked yellow card, give them this. So that now you can distribute traffic across different providers, so that again, you don't limit yourself when you're doing request to a particular provider. So I hope that answers that particular question. For the second question, which deals around with blockchain in infrastructure, is that what people don't know is, or what I rather find most people don't understand, or not really understand really, but most people are not really aware, is that, not really aware, but people don't think of it that way. People don't think that M-PESA is SMSing money. M-PESA is literally just SMS, because I simply send you a message like, chop, kaching, congratulations. I've sent you this and this. That is literally, so the technology that powers M-PESA under the hood is SMS. Because without you getting that money, I don't trust you've sent me money. At the moment I receive that money, that's why if you go anywhere in Nairobi, in restaurant, in everything place, the key thing, they don't even worry about whether money is in the wallet or not. They're like, show me the message. So the key thing around that surrounds M-PESA is SMS, but it is not the thing. It is the thing that powers that particular communication. My first instinct when I send money is I check for SMS. The first thing the person who receives money is to check for SMS. So under the hood, SMS powers that particular payment. It powers that trust between two parties, which is peer-to-peer that are receiving money. It's the same thing, let's say, with blockchain. So especially for the concept of stablecoins, which is there's a very high chance, for example, if you go and use paid money or paid HQ, and you send money, you receive money from you, let's say you get PaidHQ can give you for like a virtual bank account from the US if you're a freelancer. So PaidHQ mostly deal with the freelancers, for example. So the key thing is not, the key thing is that it will power the infrastructure layer. Like for M-PESA, what powers the infrastructure layer is that SMS. That is the key thing that kind of like powers, we are SMSing money, whatever the case. So even for blockchain, as we get, especially for cross-border transactions, because we found that cross-border transaction is very, very expensive. It's way, way too late. And we are having an emerging kind of like, most people are gig workers, sort of like, they're not in formal employments and all this sort of stuff. So let's say you get a virtual bank account in the UK, be it SEPA Instant, be it SEH, whatever the bank account that you get, for example, when the user pays you, for example, in the US through their bank account, and you instantly have access, let's say if you have a paid money wallet, you instantly have access to that money within Kenya here, and you spend it in M-PESA, it's exactly the same thing. Because blockchain is pretty much instant and the fees are very low, for example, so there are not a lot of effects issues that are involved. So of course, blockchain, especially for cross-border transactions, if you try to build for cross-border, you pretty much end up with one thing: stablecoins, and stablecoins is blockchain. So of course, stablecoins will always power it is going to go like the main frontier that's going to power cross-border transaction. Not going to be a frontier as the thing that people think about. Like the same way you don't really think about that I'm SMSing money. You just think I'm sending money. The SMS is the infrastructure side of things, where we are just having users with the interfaces they are used to. For example, it's the same thing. So somebody in US can easily pay me. I don't need to worry about blockchain and stuff. Me, I just want to withdraw my money to M-PESA. But the technology that has powered that particular movement for me to access my money with ease, with cheaper fees, has been blockchain, especially for stablecoins. So stablecoins is really coming to be a very, very big player for that particular layer, especially for kind of like APIs, especially around fintechs. Another layer that is coming, that's going to become very, very good is, especially for using blockchain, is ability to, instead of kind of like pre-funding your wallet, you can fund on demand, for example. So that's again, because I think moving fiat is very, very expensive, whatever the case. Let's say if I want to move money, let's say to Nigeria, if in case I can easily use at that particular point, if I want to send money to Nigeria, I can easily use, let's say, a Bitcoin Lightning fund. If let's say I have USDC, fund that through M-PESA, for example, buy Bitcoin Lightning, and very, very quick, let's say, go to paid money, send that money, let's say, to Nigeria. So I don't really have to have money in my wallet as traditionally with finance that exists, that I have to go deposit money in a bank or hold liquidity so that I'm able to send Nigeria because of the fear of taking a lot of time. I can easily just kind of like instantly kind of like do a fund on demand and send that money instantly without worrying about anything else. Yes. So I guess those are my two answers to those two questions. Yes.
Yeah, that's clear enough. I hope Lina is answered, and also the other Vincent that you suffered with. I know he's somewhere listening to you. So I don't want to wrap up this session without asking you, Vincent. We've talked about a lot of things, especially around the architecture, scaling. There's one person who asked, and you can respond to this together with the last question that I'm asking you, because I know you've really taken quite a lot of time. How to connect serverless infrastructure with standard payment systems now that you are heavily from a fintech background. So yeah, how do you connect serverless infrastructure with standard payment systems? But also tied to that, you can just mention something about security, API security. How do you approach it? Because it's one thing to build a system, but another to build a secure system and secure APIs. So in 2 minutes, if you can respond to that as we wrap up.
Okay, so I think I'll pick the serverless. So for the serverless, think of basically what we've demoed today. It is serverless, but we own the infrastructure. That's the difference. So a serverless is simply how to connect serverless is because remember behind a serverless function, what you simply have is just a normal bit Python script. It's just a normal Python application, for example. It can even be Python, a fast API, Flask, a Golang script, for example. So the connection between those and any kind of like payment gateways that you do have, that is done within that your script. And of course, within serverless, for example, if you use so like AWS, you can sort of like set environments for those particular serverless when it is run so that it reaches the environment that you set up. For example, if you use Google Cloud Functions again, you can also set up those particular environments so that the logic, let's say, for your payment gateway just exists within your script, for example. So if you, let's say you have an M-PESA script, you can say this is the serverless function for M-PESA, just as the normal function that you do. It's just a function, let's say, to call M-PESA, construct consumer key, do all of those things, call M-PESA, call a bank, do those things and call that particular bank. So the logic for that just runs in your, for lack of a better word, the environment, of course, you can set it up on whatever the environment that you use, for example. Then that's pretty much it. Then the key thing of a serverless is it gives you a gateway that you are able to set up and a way to serve that your serverless link, for example. So if you add a function, let's say for calling M-PESA, then an easy way that sort of like AWS and the likes of Google Functions gives you is that you just get a URL that your link is under and people can call and the function behind your script will be called. So yeah, it's you just call that through code and sort of like have access to it through the URLs that you get with the cloud providers. For how to kind of like build API security, and I think I alluded to that before I started the demo, which is, for example, there are two-tier way which, for example, you do. So especially if you deal with fintech data. So the very first thing you have to start with that you realize with, for example, is kind of like authorization. So that has to be the key number one, which is you may have a very, very high security in terms of how your servers communicate, how you store data at rest, how you store data, let's say, for example, in transit, have it SSL, all of these sort of things. So you start very, very simple. Within is your application secure, for example? And application secure is that, when we talk about authorization, can person A allowed to access resource B, for example? If they are not, they should not be able to access that particular resource based on the permission that they do have. So I think that becomes kind of like the very first layer of how to protect, because again, if you don't have that layer, but you have all these other security things, it doesn't matter. Somebody can come with anything and have access to other people's data. The next thing is using signed, this, especially if you deal with buckets. So using like signed URL for your buckets. So I think that also becomes a very important layer, because again, we use S3 buckets everywhere. You go to any application, there's a 99.9% chance they have an S3 bucket. Like I think there's almost 100% chance that they have an S3 bucket somewhere. So use S3 URLs whenever people are accessing your blobs, for example, so that does not become a kind of like an attack vector for you. Then now you go to the next step, for example. So what is your infrastructure layer kind of like security look like, for example? So of course, you have to communicate now through SSL, for example. That becomes kind of like the key thing, ability to have certificates, renewal certificates, for example. If you have microservices, again, generate kind of like keys for each of your services, for example. It's kind of like a public-private key, which, for example, if your client, like this, we saw our client was calling our servers, those things have to communicate through kind of like a well-signed key, generated keys that serve us to verify kind of like the, believe the public-private key, for example, basically, where the public key is used to kind of like sign off a request whenever they are calling. Remember, that is at HTTP level. That's not even at code level, HTTP level, for example. Then, of course, now you go now another layer, for example, for your infrastructure. And that now becomes first of all, don't host your own database. I think I should even start with one. Security rule number one. Don't host your own database, for example. Get a managed database that has everything in kind of like managed for you. Then the next step, in terms of what you have, especially when you're doing database at rest, make sure that at rest your database is encrypted. So when somebody comes to a database, somebody cannot dump your database and just have access to the data. Your database has to be encrypted at rest, for example. So then the next layer that again you can also have around that is that kind of like there's something called data hiding, which especially for user identifiable information, for example, make sure that is kind of like hashed. Then finally, in terms of how you communicate, which is now the different systems, for example. So that one you have to use two things, which is, I think, HMAC and IS encryption techniques. So for example, let me say, for example, in use case scenario, I'm calling API to make a payment request. I have my payload, for example. So the key thing is that, let's say somebody's calling my front end or somebody's using our API. So they have our API key, and that API key has a secret. So what we'll basically do, the generate API key in our system, we'll let them generate a signature and a timestamp with our headers. Take the data, let's say they're posting some data, take the data that they're posting to us, use the kind of like use the secret key that they got when they entered the API key, for example, to sign off that particular request. For example, when they sign that particular request, they put that signature on the header and say, this is, let's say, for example, X PayHero signature or X dollar signature, whatever the case. This is the timestamp, for example. Then this is my payload. This is the URL that I'm calling. Then for us, when we get that request on the server, for example, we'll take that request, then we'll decode that particular request, for example. Once we decode the request, we'll check, does it match? First of all, was it signed by the secret key that was given? Was it signed by anything that we gave the user for doing those particular signing? Is this the API key that signed it? Does the payload they've sent us match the payload that has been signed? For example, is the signature valid, for example? So at a communication level, that's again very, very important, so that now you don't have a man-in-the-middle attack and just send a request to you or listen to you and just fake somebody sending a request. You are able to make sure that this request is coming from person A because person A was given a signature, was given a secret key that they were using to sign that request. And you are able to decode that request on your system and verify the content that they were sending. If the content don't even match the payload and the path they're requesting. So for example, if it's a REST request, they say we're requesting /users1, for example, and you decode the signature and realize it's not users1, you reject because that's not what they're requesting for. Their payload, they're saying user ID is 4, but you realize the actual payload from the signature, user ID is 1, you also reject. That is the data validation layer, but you also have to verify the signature and make sure that the signature actually matches something that was signed by a key that you issued to them, for example. So yeah, Of course, you also have to add HMAC to that, because HMAC now gives signature, so that now somebody may get how to sign off those particular things. But if the signature is also wrong or off even with a small digit, then you're like, oh, that signature is also still invalid. So I think in a simplistic layout, for example, that is a way to approach it. There are a lot of things that involve infrastructure in terms of having jump servers, making sure your servers are passwordless, for example. Don't have your servers with passwords. Make sure that you use kind of like SSH keys when you're logging into your servers. Rotate your keys frequently as much as possible. Don't open ports. If you have your infrastructure, make sure that your infrastructure there's just make sure you have a load balancer that exposes to the public. And I think for people who did computers, for example, if you're making requests to public networks, for example, don't use your servers that run your application to make public network. Set up a NAT gateway, so that the NAT gateway is the thing that actually makes a request. So the key thing is always to reduce the attack vectors that you can able to be attacked with, and just set up properly your ETH0 across your different nodes. Yeah, then you'll be good to go. So I think in a very simplistic way, of course, I'm not a security expert, but that is a very, very good way to start, which if you get a security expert and they have to do like all of this on swap and everything else on your systems, then you've set up a very solid foundation to make sure that at least your servers are hardened. Yes. So I guess that is kind of like my answer to that. Yes.
Thank you so much, Vincent. I know in as fast time is way spent, but for anyone who is dedicated to learn and move, I know this session has been very informative to them. Also, appreciate your expertise, Vincent, especially on such topics, because, well, where else would we get such solid information coming from a senior like you? And I can listen and tell this person really, you are what Africa needs, you are what the world needs, you are what East Africa and Kenya needs. So we are so much humbled to have you today in our session. For those who are still in the session, Vincent is part of the fintech ecosystem in Africa, and he's also on social media, Vincent Omondi. You can check him out. I don't know if I'm the only one feeling we should have had part 2 of this, maybe in a different session, but by public demand, if you feel you can have part 2 of this, or if you feel we really need part 2 of this, you can let us know in the live chat, or something that you feel we can focus on. But I really feel Vincent has really given a high level sort of presentation today. So as we come to a near end, this is who Vincent is on LinkedIn. Allow me to share that on LinkedIn. Yeah, so this is Vincent Omondi on LinkedIn. So you can see his profile. I really love his about. I build solutions to problems. You haven't seen very funny jargon there. I don't know. We built those kind of funny things devs put, building, I don't know what with what technologies and tools and what. He's focused on solutions, and I think that's something. It's a mindset that possibly some of us can adapt as engineers or devs. So focusing on building solutions. Yeah, you can check out his profile about what he does at PayHero, at Paid, and interact with him. I believe because this profile is public, so depending on how you'd want to follow him up, but he'll also let us know much about him later. As I come to an end, also allow me to appreciate someone who is not here, but works with Vincent. That's Ronald, a good friend of mine. Thank you for also having this particular opportunity to, or rather, this particular session to have one of your devs to come and share with us. So Vincent, because you work with PayHero, as you wind up and also give us your parting shot, because we've run out of time, you can let us know what you people do, and if we can plug in, or how does your solution help the world, or Africa, or Kenya? What is it all about? Can people plug in? Is it something private, or what do you people do? Let us know, and also pass our regards to the rest of the team. So Vincent, your parting shot, as you also let us know what that solution is all about.
Okay, so I think before my parting shot, I think I'll pretty much just go what we do at PayHero. So what we do at PayHero is we build kind of like an end-to-end payment operation solutions for businesses, especially micro SMEs across Africa. So when I say that, for example, what I mean is that, for example, let's say, for example, you do a fintech. I remember payment integration, integrating 80 plus payment providers in Kenya is not your mode. Your mode is probably, let's say, to provide credit for freelancers, to provide, let's say, credit for, let's say, for SMEs, for example. So payments is very complex and segregated. It can quickly become a business line for you, even if it's not a business line. So what we give you is we give you kind of like a service that helps you handle everything that involves payments for you. So that is the ledger service, connecting to all of these particular providers, for example. That is communication for you, so that in a very easy way, and we provide you all of those things in one single API. You never have to call 3, 4, 5, 6 APIs. Just call one single API, and you're able to collect money directly into your bank. You're able to collect money directly into your pay bill. And the beauty of that all is that we never hold your money. We simply just kind of like a merchant of record. We communicate with somebody to tell the provider to send money from one provider to the other. And we also now, if you want to scale across Africa as a business, we also allow you kind of like to scale across Africa as a business. So you're able to do 35 plus African countries, not just in Kenya. So if you are a business that's going borderless, yeah, you can get all of those things, for example. And plus what we give you is, I think is first of all, simplicity. We simply simplify payments and make payments get off your way, in short. So you have to measure in what you do. You have to measure in your mode as a business. So that is mostly our business, our proposal. For example, as a business, we also help with the deploying, and yeah, getting started is quite easy. Like literally, you can integrate PayHero, I think within 20 minutes you are live, and I think that is even overkilling it. You're live and you're already receiving payments directly into your tails and pay bills. So for us, we don't have the concept of a PA of wallet for most part. You simply get money directly into your channel. And the beauty of it is that even if you have your own credentials, for example, that is, you can bring your credentials directly into a system, and you're still able to connect to around 80 plus different providers that you'll get across Africa, for example, that matter. So that is sending money to West Africa, South Africa, Central Africa, in except of, I believe, the Egypt and the Morocco, pretty much sub-Saharan Africa, we've got you covered. For my parting shot is, there has never been an easier time to build, for example. I think the key thing that I'm noting, especially around Africa generally, is that we're starting to have localized solution. There's never been a better time to build. There's never been a better time to learn. There's always kind of like a formula that is done that AI will replace humans, whatever that generally will happen. And I think I'll just notify people is that, or tell people that mostly have this particular formula. Yes, AI is getting good. But remember, I've mostly trained in AI space. I've worked mostly, especially dealing with AI and data space, for example. And AI is going to be a very, very good tool. It's going nowhere. It's going to change, of course, how work is done, for example. But remember, the key thing is that there'll just be new job opportunities that AI will create, for example. So will you have the skills to do that particular migration? So that particularly means that right now, having solid skills is very, 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 very important. Handling foundational skills is very, very important, because this is going to be a tool that is going to define how the future's work is going to look like, especially within our particular space. So be very good to tame it. Don't fear it. Be very good to tame it, for example. And I think the future is just the limit for us in terms of what we can do with AI. And also remember, for example, in Kenya or even in Africa as a whole, 40%, 60% of people still have cell phones. So it means that we have a lot to change. So can you take this beautiful tool been given and can we build solutions that can especially help transform Africa as a continent, that can help us open new frontiers, so that as we move through that particular space in which we're becoming first world countries, for example, I know technology will be at the forefront of it. So it's never a better time to learn. It's never a better time to become good. It's never a better time to be in technology. So I guess, thank you so much. And thank you for having your time and thank you for joining us.
Okay. Yeah, Vincent, that is well heard. And for the parting shot, I guess that's very clear. We need to build solutions for Africa. We need to localize everything, but also, it comes with innovation. So thank you so much. For our audience, Vincent took his time to volunteer. We don't pay our guests, nor do we appreciate them in terms of monetary value. They just volunteer. So I guess if you've been impacted by this session, also any other opportunity you get to ever volunteer elsewhere, please do so. But also as a way of appreciating Vincent, you can show that kind of love to him, maybe on his LinkedIn page, what you learned, what you picked up. Possibly if he's open to conversations, you can also pick them up with him on LinkedIn. So we have come to the end of our session today. It's been quite long, but very informative. We really hope to have so much of this. And also, because he works with PayHero, what they do, you can go check PayHero, PayHero Kenya, Google them, see what they do. If it works well with what your organization does, right from, because I've seen they do payment right from Mama Mboga, literally. This is a real example of impacting Mama Mboga. So yeah, you can see how you can integrate your simple solutions with their APIs. If they work well for you, you can pick them up. Again, to our community, if you're not part of our YouTube channel, subscribe, share with your friends, let them know what we do. Invite many more to come get impacted for free. We share knowledge for free. And I hope to see you next time in our next session. So Vincent, receive your last final virtual claps from the community, and also as an appreciation to what you've done. Your expertise has been of great importance to us, and we are glad that you're contributing to Africa and Kenya and generally the world in terms of coming up with solutions that make our life better. So until next time, guys, thank you. I've been your host, Douglas, and I hope to see you in the next session. So bye-bye and see you next time.